good question. All right, let's get started. So today we're talking about exceptions. This is kind of a new topic. And yeah, I'll just go straight to the question. So the question is, what's the difference between the capital E exception and the rest of the exceptions? So let's check out the Java doc for like one of the exceptions that we've been talking about. This is old. This is Java doc for 17. Let me see if I can get the 14 docs to come up just by. Nope. Okay. Anyway, but this is old, but what you can see here, I'll blow this up, is that Java lang exception, capital E exception. So remember, everything in java.lang is sort of automatically available for you when you use Java. So all of the classes in the java.lang package that includes java.lang.string, which we use without importing, those are all available. Java.lang.object, also available. So what you'll see here is that java.lang.number format exception is a type of exception. It's it's a descendant of exception. And so we'll talk a little bit about more about this tomorrow when we talk about different types of errors in Java. So essentially, throwable is anything that can be thrown in Java. So throwable includes two subclasses. Errors and exceptions. Again, we'll talk about these tomorrow. Exceptions are the ones that you're going to work with more often. Exceptions is a pretty big category. It includes all sorts of different types of problems. But there's a specific, let's see, let me go back to I kind of lost the plot here. Yeah, there's this specific type of exception. It's called a runtime exception. And these runtime exceptions are, again, this is material that we'll talk a little bit more about tomorrow, but it's fine to get a little ahead of ourselves. The runtime exceptions are exceptions in Java that you don't have to declare that you throw. And we'll talk tomorrow about writing methods that actually maybe on Friday, we'll talk about throwing exceptions and designing your own exceptions. And there are exceptions in Java. So Java has this notion of what are called checked exceptions. We'll talk about this tomorrow and then get some practice with it on Friday. A checked exception in Java has to be declared to be caught somewhere in your code. So if you write code that throws a checked exception, you can think of the checked part as being checked by the compiler. So if you write code that throws a checked exception, you must catch that exception somewhere, or the compiler will complain. And so I don't know if there's a good way for me to show this on the playground. This is so one of the things that I'll point out is that on the playground, all of the loose code that you write in these playgrounds. Let me find another one that doesn't have my face all over it. Okay, here we go. All the loose code that you write in these playgrounds is wrapped inside a method that is declared to throw an exception. And so that's why, even in this, if I wanted to say, throw, again, we'll talk about this new exception here and run this, it's just going to throw that exception. On Friday, we'll talk about throwing your own exceptions in the cases in which the compiler will force you to handle them, right? So, but there are certain cases where when you design a particular class or particular object in Java, the compiler will force you to handle the exception. So the idea is that the compiler knows that a particular piece of code is going to throw a particular type of exception, and then it'll demand that something catch that, right? That you need to catch it somewhere. That's what's happening if you've been working on the MP and you've been using Jackson. So when you use Jackson, the deserialization and serialization library that we worked with in the past, as we showed in this example that I just deleted, I'll get it back. Jackson can cause an exception if there's a problem with the JSON. That's one reason, or if the JSON doesn't match the class that you're serializing into. That's another case in which that can happen. But yeah, that's a great question. So there's lots of different types of exceptions. The one that we were looking at, the number format exception, is a subclass of a legal argument exception, which is a subclass of runtime exception. And so Java has these hierarchies that have been created for exceptions. And part of the reason for that is exceptions, you can see, it's just another Java object. The only thing that's special, if we go back up here and we look at throwable, is that it says only objects that are instances of this class are thrown by the Java virtual machine or can be thrown by the Java throw statement. So we're going to talk about throw on Friday. And at that point, maybe a little bit tomorrow, and at that point, there's this throw statement in Java where you can actually generate an exception. So today we're talking about catching exceptions that can occur. There are places where you can actually throw an exception explicitly. It's like if something goes wrong. So if you think about the example we looked at where we did well, actually, let's think about Jackson, right? So at some point, those exceptions that Jackson can potentially generate or throw are in the code. Right, so if we went through the Jackson source code, we could find the place where those exceptions are being generated. So for example, if it's trying to parse that JSON that you give it and something goes wrong, right? So for example, if we break the JSON in some way, then we get this JSON parse exception. And that's being generated. You can actually see the specific place in the Jackson source code that, again, if we had access to that, we could find this line. And there's going to be a statement there that says throw, right? Because this is something has gone wrong. The other, example that we gave is that we can have cases where the JSON structure doesn't match the object that we've told Jackson to serialize it into. And so we have a different type of exception, unrecognized property exception. And you'll see that that's also being thrown by a particular piece of the Jackson source code. So if we went and we found the Jackson source code and sat down, and there's quite a bit to it. I don't suggest that you do this, but you could find places where it's actually, well, you know what? I don't know. Why not? Let's see here. Let's look at, I think it's going to be in here. Let's see if we can look up this piece of code online, actually find the source code for this. No, this is the Java doc. I don't want the Java doc. Here's GitHub. Okay, here's the actual source code. I love GitHub. And then let's find throws IO exception. What's the one that we're getting here? It's this unrecognized property exception. Find unrecognized. Here's one example. I'm not exactly sure what path. Like there might be a couple places where that gets thrown. It looks like there's only one place in this file. Well, okay, no. This is correct, I think. Let's look at the line number back here. It says property exception. What file are we in? We're in deserialization context. This says .855. It wouldn't surprise me if that's actually the right spot. Let's look up here a little bit. Yeah, this is in a comment. We're probably using a slightly older version of Jackson on the website, or the line number is a little bit off, but this is, I think, where this is coming from. And you see this throw statement that we're going to discuss later. So this is a case of an exception that's there's really two types of exceptions if you think about it. Let's go back and look at some of our other code. We don't get into this distinction today. It's something that we'll get to tomorrow. But if we look at, let me just fast forward in this walkthrough and we'll get to this point. So if you look at this code, this line is generating an exception, but it's not using the throw statement. So this is an example of an unchecked exception. Unchecked exceptions in Java can't be checked by the compiler because the compiler isn't smart enough to realize that this is a problem. We've talked a little bit about the compiler in the past and the type of things that the Java compiler can figure out, and the type of things it can't figure out. And it's too dumb to figure out that O is null and I'm about to dereference it, and that's going to cause a null pointer exception. But this is a line of code that's going to throw an exception that the compiler couldn't predict. So you don't see an explicit use of a throw statement. Same thing here. When I try to do an array index operation with an invalid index, this is an empty array and I'm trying to get the first element. The Java, again, this is an unchecked runtime exception. The compiler can't predict that this is going to be the case. If the compiler could predict this, it would stop me from doing it in the first place, right? Like the compiler doesn't want my code to generate errors. Like null pointer exceptions are a problem. So if the compiler could figure this out, you kind of wish it would be able to, then it would stop me. It would say, no, this code won't compile. I've noticed a problem here. There's a null pointer. You're about to have a null pointer exception. This, on the other hand, again, let's see if we can find the code for Java integer source code. Let's see if we can find the source code for Java laying integer. Yeah, here's some version of it. Again, I don't know how up to date some of this is. This is from the so let's look at the parse int. And you'll see, okay, so see first two things. First of all, this is declared, and we'll talk about this as we continue to talk about exceptions. This is declared to throw a number format exception. And you'll see that as it goes through here and it tries to, there's code in here, right? Like, you know, you might be surprised to find out that it's not magic, right? That somebody wrote this code at some point, and it takes a string, goes through, and there's some complications here. You can have a radix, so you can tell it what base the string is in and stuff like that. Let's see if we can actually get that to work in a minute. Anyway, but you can see there's a couple of places in this piece of code where it's actually, and there's an exception being thrown. And it's basically saying throwing a number format exception if there are certain problems with the input string. And this is more complicated than you might think, like I said, because you can do things like this. I think. Let's try this. Oh wait, that's not even valid. No, yeah, it is. Okay, and then let's print it. Not a number. Oh, it doesn't like this. Let's see here. Integer Java radix. How does this work? Oh, sorry. I need to actually give it a radix. Okay, so I think I have to do it here. So this will parse it as base 16, and then let's make this like that. And now you'll see that the result here is 22, right? Which doesn't make sense unless you realize that I've asked it to parse it in base 16, right? So in base 16, every digit there are 16 possibilities. This is a commonly used number system. You see it in hashes. You see it throughout computer science. There are 16 different symbols that we use. We use the traditional numerals 0 through 9, and then we also use letters A through F, 6 more symbols, A, B, C, D, E, F. And so for each place in the number, we can represent 16 different potential symbols. And so this number is, if you think about it, if I do this in tens, right, it's 1 times 10 plus 6. If I do this in base 16, it's 1 times 16 plus 6. And then I can also do things like use the symbol E. Now it's 1 times 16 plus 14 because E is the symbol 14. If I use F, this is going to be, if I use F, it's going to be 31. So anyway, so the parsing for the string is a little more complicated because that it does accept this radix argument. When you don't call it with the radix argument, you're going to get it's going to use base 10, and so in base 10, this isn't a valid number. I would need something like this. Okay, weird digression into numbering systems. Other questions about this? So we'll talk a little bit. We talked about try catch. It's always a little bit tricky for me to figure out kind of where to start talking about exceptions. This semester, I decided to try to talk about it, first of all, from the perspective of a user. Because when you probably noticed on the MP that there are certain places where the compiler is basically preventing you from running code because you haven't declared how you're going to handle the exception. And this is true with Jackson, right? So if you look at this piece of code, right, this we can, and I just want to clear up a little potential piece of confusion here. So the question is, why can I run this in the playground without it being inside a try-catch block? The reason is because when you run this this loose code in the playground, code that's not inside of a class definition, the way the playground works is that it wraps it inside a method. That method is declared to throw an exception. And so it's allowed to not have to use try-catch. Normally, what we'd want to do in a case like this is we'd want to wrap things in try-catch, which is one of the options that you'll get when you get this error that there's an exception that you're not handling. And then you can do something about it. There's a couple of different options with error handling, and we'll go into this more later, right? Sometimes the right thing to do is to handle the error. Sometimes the right thing to do is to let the method that's calling the method that generates an error throw the error if it doesn't know what to do. It really sort of depends on the situation. So there's a couple of different ways to handle that. Other questions about exceptions? And yeah, so if you look at let's see here. If you look at all these different exceptions that are thrown in here, null pointer exceptions, array index out of bounds exceptions. There's a list index out of bounds exception that you can get if you work with an array list. All these different types of exceptions, they're all subcategories of capital E exception. And when we talk a little bit more about the categories next time, we'll also distinguish between the checked exceptions and the unchecked exceptions. So there are certain exceptions that the compiler can't tell when they're going to happen, and so it can't force you to wrap it in a try-catch. Null pointer exceptions are an example. So if we look up, let's see here, null pointer exception, Java 14. Just give me the docs. Here we go. Yeah, so, and you'll see again, subclass of runtime exception. These are this is a non-checked exception. So the exception category has lots of different children, but the runtime exception category are exceptions that the compiler does not require that you wrap and try catch. And the reason is the compiler can't tell that these errors are actually going to happen. And we'll also talk a little bit more about exactly why this is and what that means, right? But part of the semantics here are that these are usually the result of programmer error, like you messed up, you did something wrong. The checked exceptions more frequently can be the result of things like a bad input provided by the user, or you imagine some feature of the universe that's not the way that you thought it would be. Like you're trying, let's say you're trying to make a web API call and there's no network on your Android device, right? So when you make the request, what do, right? The way that the request library that we're using for the MP works is that you have to set up an error handler, which you guys are doing as you're making the request for MP1. But in other libraries, it throws an error, right? If there's a problem, and then you have to handle it. So it's just a different way of doing error handling. So, and if you look in here, let's go into the runtime exception category, make this a little bit smaller. There's a lot of things that we just saw. The null pointer exceptions are in here. Array store exception, array index out of bounds exception must be in a different subtree. There's something called a legal state exception and legal argument exception. So remember in the past we've had this. What we've been doing so far is we've been showing you guys and expecting you to use assert. Actually, one of the things that assert does, and you might wonder, and we'll talk about this when we talk about throw, what does assert do? Assert actually throws a particular type of error, which is called an assertion error. This is an assertion. So when you use the assert statement, if it evaluates to false, so essentially, let's go back into the playground here. I can go use any one. Use one again. It's not. So when I do something like, I'll keep the rest of this here. Did I fix this? Okay, there we go. So when I do something like assert false here, and I need a semicolon. There we go. You see that there's an assertion error that's thrown. This statement is really almost equivalent to the following: if not false, throw new assertion error here. And if you look at what happens, it's going to do the same thing. The line number changes a little bit because we have this if statement. But you can almost think of assertion as expanding to this. Now, one of the reasons why people use assert is that it's possible to turn them on and off in your code. And we talked a little bit about this when we introduced the idea of using assert. There are times when you want certain assertions to happen, like when you're building stuff and testing it, and then you might want to actually disable them when you deploy code to production. I'm not sure that's always a great idea, but I think people in the past used to think, assertions are going to slow the code down, and so we use them while we test the code and while we develop it locally. And then, for example, if you were shipping your Android app to deploy on the Play Store, you might turn the assertions off when you build it for other people to use. There are different types of, and we've been kind of using assert in some places where we'd probably be better to use something like a legal argument exception. So we'll talk about those over the next couple days. So when you have a method, and that method, we talked in the past, let's say I have something like public class container, and then I have a constructor for the container that takes a size, and I expect that size to be positive. remember we had this problem where it was like, I can't return, right? If I return out of a constructor, the caller still gets an object back. And if I haven't properly configured the object, then I have a problem. And let's say that I have like a private int array here that I need to set up. And basically what I'm going to do is I'm going to say array is equal to new int size. Now I've got to make sure that that size argument is positive. What we've been doing is we've been saying assert size, is greater than 0, right? Or, bad size. You could do something like this. The problem with this is that when I turn asserts off, these checks go away, right? And, unfortunately in Java, assert is a little bit of a fragile mechanism for this reason because it's not always turned on. It's turned on in our playgrounds, and I don't know if it's turned on Android Studio or not. I'll have to check. But the right thing to do is actually to do this. So we say if size is less than or equal to 0, throw new illegal argument exception, and we say size must be positive. And this will accomplish pretty much the same thing. So I say container good is equal to new container, and I provide it with a positive value, I'm fine. Container bad is equal to new container, I get 1. Now I get that illegal argument exception. That's usually actually a better way a better thing to throw when you meet this. We just haven't gotten there yet. We were using assert because it's kind of simple, right? It's also something that you do use during testing. So, but we'll start migrating you forward in the future to start to use this to do argument checking when needed. All right, other questions about assert or errors? One thing I'll emphasize, and we'll have some homework problems on this again, is that errors in Java are just objects. You can pass them to methods, you can extend them, you can, they have properties, so for example, if we let's look at throwable. I don't know if throwable defines too much. It has some constructors. Yeah, so for example, get message. So keep in mind, throwable is the parent of exception, which is the parent of, anything that can be thrown is a throwable. So anything that you can catch in a catch statement is going to have all of these methods, right? There's a get stack trace method. There's something called print stack trace, which can be pretty useful. There's a toString method, which is what's used when you pass it to, this is inherited from object, right? When you print the exception. There are, so there are certain exceptions that are caused by other exceptions, and so when I wrap an exception, I can set this cause variable, right? So I can have kind of a nested exception. So there are some exceptions where, in order to figure out what really went on, I have to take the exception and unwrap the cause that's inside of it. So that's here. You can see null the cause is not always set, right? There are certain exceptions that don't work this way. And then, this message is usually, I think, part of what's actually included in the toString. It's similar. So if I go back and let's see here. So let's wrap this in a try catch for fun, because we can do that. We'll do catch legal argument exception E. I have to spell it right. Right. And then because exceptions are just objects, I can print my exception. Now I'm doing this. I can print its message. Now it's just going to be size is positive. I can print, I don't think this will not have a cause. It's just going to be null. But it inherits all of these methods. And it's also possible the legal argument exceptions have some of their own methods. I'm not sure if they do or not. Let's see here. Legal argument exception. I don't think I've ever used the search. I think it works pretty well. Let's see here. Method summary, constructor details. No, it doesn't look like. Yeah, so this particular exception doesn't declare any new methods. It just inherits the stuff that's already there. So anyway, yeah, so this is one of the things that we'll start working with, right? When we go forward, we'll at this point we'll stop saying you should assert, and we'll start to say reject certain arguments by throwing illegal argument exceptions, which is really a better way of doing argument validation. The illegal argument exception is created for this purpose, right? As its name implies, it's designed to be used when there was an illegal argument. All right, questions questions, concerns, stuff in the lesson you want me to go over, anything that's on your mind. I'm here to listen and to provide answers if you have questions. Errors and exceptions. Yeah, good question. So let's go check the Java doc. Java, do we have throwable 14? There we go. All right. So let's check. Let's click on it. Yeah. So and this is really the right description. It says an error is a subclass of throwable that indicates serious problems that a reasonable application should not try to catch. So, for example, in our examples that we've been showing you, you've been catching exceptions, not errors. We don't catch throwables. You can catch throwables, right? So, for example, I can go back here and I could say instead of catching a null pointer exception, I could say catch throwable E and say, actually, I don't know if this is going to work or not. Let's try it. Oh, it does. Works fine, right? So I could catch any exception, right? And that includes errors. Now, the distinction is that typically an exception is something that the program might be able to recover from. An error is not considered recoverable. So let me give you an example. When the code that is, there are certain conditions. So and this gets into some stuff that we haven't talked about. So let me try to explain it at a high level. When your program is running, there's this idea that there's a thread of execution. A thread of execution consists of a single sequence of steps that the program is following at any given time. Many programs, including the MP that you're writing, can actually have multiple threads of execution that are active at the same time. So, for example, when you guys have been working on the MP, and you haven't really had to think about this too much because we haven't really talked about it much, and we might get to it later in the semester just very, very briefly. But there are really multiple things happening in your application at the same time. There's not just one sequence of instructions that's being executed. The server, for example, that runs next to your MP front end, that server runs in its own thread. If you look at the code that starts it up, you can see where we create a new thread in order to run the server. If we didn't, the app wouldn't run. We actually need more than one thread because we need one thread to run the app, one thread to run the server. There's actually a small number of other threads that are created to support making web API requests in the app. And so at any given point, there's actually multiple paths that the code is executing at the same time. And so if one way to think about the app is when it makes a network request is that the code that's running the app makes the request, and then it goes off and does other things. Might update the UI, like you might be able to scroll around. The server-side code is handling the request, and then so that's off doing its own thing. So the client-side code might be updating the UI, the server-side code might be handling the request, like loading the information out of the map and stuff like that, sending it back. When the request comes back, then the server-side code goes back to waiting for more requests, and the client-side code picks up the result and updates the UI or whatever. Okay, all to say that it's possible in Java for these threads to die, and sometimes for them to be killed explicitly. I happen to know more about this than I probably should because this turned out to be, when we were building the sandbox, the playground that your code runs in when you run it on a website, this turned out to be one of the most difficult things to get right. So in Java, there's a mechanism that exists to stop a thread from running. And what I can do is I can communicate, I can essentially send that thread a message that says die. It's actually thread.kill. I don't know why the terminology here is so violent, but it is. And there's actually, if you use Unix-like systems, there's actually a kill command. The thing that's a little sad is that kill is actually used to send a message, right? So it's actually friendlier than it sounds. There is a message that says die, but there are other messages too that say other things. So anyway, so when I want to stop a thread, I can send it this particular type of message, and it's supposed to stop. And the way that this is implemented in Java is that the thread that's running will suddenly throw a thread death error. And so again, we could look this up, Java thread death. This is going to be a subclass of, you'll see it's a subclass of error, right? Which is a subclass of throwable. So this is an example of, and it says an instance of thread is thrown when the thread.stop method is invoked. And an application should catch this only if it must clean up. The idea is that you're supposed to stop when you receive this particular message. Now, the thing that we had to worry about when we built the sandbox is that what if you wrote code that doesn't want to stop? And so anyway, I won't go into the details, but it turns out the fact that this exception can be thrown caused us a lot of problems. And the person who was working with me on this project did some really elegant work to work around this that works, right? That we have some great tests for. But anyway, so all to say that errors are not things that you are supposed to recover from. And if we look at the list of potential errors, assertion errors that we've been using, right? That's the assertion error really, it kind of means like something is badly wrong, right? Like something that I thought was true about the world is not, and this is a problem. You've got thread death. There's a category of stack overflow. Let me look. Let's see here. Overflow. Yeah, here we go. Stack overflow error. This is a subcategory of virtual machine error. So you'll see out of memory. If your program allocates too much memory and the system decides I've had enough, this is what will be thrown. And again, these are not conditions that you're expected to recover from. Typically, people don't catch these at all. If you do catch them, usually it's just to do some logging, right? It's kind of like last step before I'm about to die, right? Usually right around the time you get an out of memory error is right around the time that process, that program is actually being killed by the operating system. So, some of you may have had to force quit Android Studio, for example. Like that's kind of the same thing, right? Stack overflow errors, we'll start to hit those next week once we start talking about recursion. And then, there's something, I don't know what internal error is. These are always fun. I like this one, unknown error. That's a good one. That fills me with confidence. Let's see here. Thrown when an unknown but serious exception has occurred. Yeah, okay. I guess this is just like a dumping ground for problems. So yeah, the idea is that exceptions are both errors and exceptions are catchable, right? I can catch anything that's a throwable, but I'm not supposed to try to recover from an error. I might, like I said, do a little logging, or I might need to do some shutdown stuff. Like let's say my program runs out of memory and I want to do a little cleanup before it exits. That's okay. If we looked at thread death, if the thread is asked to stop and it needs to do a little bit of work to clean up, that can actually be really important. But we're not supposed to try to go on, right? With an exception, the whole mechanism behind try catch is designed to allow you to escape from the potential problem. Sometimes you can, sometimes you can't, right? But so sometimes it might return an error code or something like that. Or sometimes, for example, certain types of errors that we don't anticipate, like null pointer exceptions, do tend to crash the program because they're the result of programmer error, right? Like for example, if I'm trying to load, like let's say I have a reference and it's null and I'm trying to call something on it, how am I supposed to recover from that, right? Presumably I needed to make that call and it needed to work and I needed to use that information in some way, and so it's not clear that wrapping that in a try catch is really going to be all that helpful. But anyway, this is the high level distinction. We'll talk more about this tomorrow. Tomorrow lesson is just going to kind of get into the three categories of throwables. So you've got your errors, serious, not much to do about them. Your runtime exceptions, usually caused by programmer error, not checked by the compiler, and then those checked exceptions, which the compiler is actually going to force you to handle somehow. Good question. All right. Try catch and assert. So yeah, another really good question. So try catch is the mechanism that we use to handle problems. Assert generates a problem, right? So let's actually use them together. This is a good question. We kind of see them side by side. Where am I going here? Okay. So let's do this. Let's say, let's see what just happens if I say assert false. Right? So if I run this, what I'll see is that there was a java.lang.assertion error that was thrown. I can catch that. In order to do that, I have to catch, well, in this case, I'll catch assertion error, E, and then I'll say I'll print it, and then I'll go on. Let's see here. Why is this not running, or, oh, do I need to catch, let's see here. I don't know why I feel like this is running again. Let me try it. Oh, am I not allowed to catch assertions? It's interesting. Let me try something else. Yeah, I think something funny might be going on with the playground. These should be catchable. Let me look it up and just make sure. This is strange. Yeah, I have a feeling that this might be something about how our playground is rewriting this code. Although, again, I'm still surprised. Let's try this. Okay. Yeah, I'm surprised that this is, and I have a feeling that this might be something, like I said, a problem. But these should be catchable, right? Let me try just throwing a new throwable test, and that works. But for some reason, I have to ask Ben about this. Why I'm not allowed to catch these? That seems odd. But I think if you did this normally, so the idea is that let's go, and we're going to talk about throw on either starting tomorrow or Friday. So try catch is our mechanism for dealing with exceptions that occur in the code that we use, so that we can move on. If I have a method of handling when things go wrong, this is what I want to use. In other cases, so for example, with the MP, for some places we're using try catch, you may not be exactly sure what to do if there's an exception. The compiler is going to force you to use try catch. But for example, with Jackson, it's like, what am I going to do? Well, it's not clear. Sometimes you just want to log an error message, and you just don't want the program to crash, right? That's sometimes okay. The assertion is really, this is really the equivalent of if not false. Yeah, those two are really kind of the same thing. And so there are, you can use them. I shouldn't say you can use them interchangeably. I mean, the assert keyword is something you can turn on and off. So that's typically something you want to use. So assert is really just another way to throw an exception. And we'll talk about throwing our own exceptions over the next couple lessons. Try catch is the mechanism for handling exceptions. So throw is saying something went wrong and here's what it is. Try catch is saying try to run this code. If certain type of things go wrong that are enumerated in my catch statements, here's what to do about it. And so I'm prepared for failures that might take place. So there's really maybe two parts of Java's exception handling system. There's the way to handle the exceptions when they occur, which is to use try catch. And then there's a way to generate exceptions to indicate that things went wrong, which is to use throw. The terminology here is actually pretty useful, right? I mean, I think this is one place where like the plain language words are actually pretty helpful to remember what's going on. So when I use try, I'm trying something, right? The idea is try to run this code and see what happens. The catch blocks are there to catch exceptions that might be thrown. So if something in the code that I run generates an exception or calls a method that calls another method that generates an exception, and that exception ends up being thrown up into that try statement, now I have some strategies for what to do when it goes wrong, right? And so let's go back and we'll look at, so legal argument exceptions are a little special because they're not usually caught, because it's usually a sign that you did something wrong, like you didn't read the documentation, for example, right? In this case, like, with this container, what I would do is I would probably say, the container documentation would say array size must be positive, and so now it's up to the user of my container class to do this. But let's look back at this one, right? So for example, here, again, we're using Jackson, and we talked about the fact that there's a couple of different errors that can take place. At least one of these errors is my fault, right? So for example, if I don't design my class properly and it doesn't match the data, that's a certain type of problem that can occur. The other problem is I just get bad JSON, right? And this could happen too, right? Like I might, my backend might not be working perfectly. Like I might make the request and it might come back garbled for some reason or something like that. And so that's another place where I could have a problem, right? And the try-catch mechanism allows me to handle this, right? So if I put all of this, and let's say catch JSON parse exception, I could do something like, if I was using Android, I could use log, but here I'll say bad JSON, and then I'll move that JSON string out of the try catch so that I can reference it there. Oh, right, I'm gonna have to import this. So let's import, oh boy. Well, let's just make this exception. And then, yeah, so in this case it's fine. Now I break it, it says bad JSON, and it prints off the information. Let me figure out where this, what the path that this is so that I can import it properly. Here we go. com.faster.json, xml.json parse exception. So these are just classes like anything else. And so if I want to use it just like anything else, I have to import it. And now you'll see the escape. There we go. Yeah, that's fine. Bad JSON. Yeah. And then I could have other catch blocks to catch the other type of exceptions. So yeah, throw is the way of signaling an exception, like something went wrong in the code, and we'll talk about how to use that over the next couple lessons. Try catch is the structure that we use to run code that might cause a problem and then potentially handle some of the problems that it might cause. Yeah. So it's the exception generating mechanism on one hand, which is throw, asserts a variant of that, and then the exception handling mechanisms, like how do I actually deal with code that might cause a problem. Good question. Let's see here. Assert error in the try catch does not run. Yeah. No, I need to go look at this. So essentially, I don't want to go too deep into the details here, but one of the things that we had to do in order to get the playground to work properly is we had to do some tweaking about how the error handling in submitted code works, and I feel like maybe we just missed this case. So let's see, good question. So when we do assert not equals null, does that mean it's generating exception? If the value is not null, yeah. So assert, let's go back. Yeah, I think it's useful to kind of just look at. So assert, let's say object O is equal to new object. Assert O is not equal to null is equivalent to, if O is equal to null, I have to negate it. How about this? If O is not equal to null, then I'd say throw new assertion error. Those two are the same thing. The only difference here, and this is a really, really good question, is that the assert statement can be turned on and off. So assert actually expands into a little bit more of a complicated structure, because when you run your Java code, you have the option of turning on asserts, which means that the asserts will be evaluated, or disabling them, which means that they won't be used. In fact, the default when you run your Java code is to disable asserts, so they're not used at all, which is one of the things that's kind of annoying about them, right? The idea here is, again, you turn them on during testing, and then you turn them off when you actually deploy things to production. But the assert keyword, when you use the assert keyword like this on line 17, these two are the same, except for this assert keyword can be disabled. Whereas this code is always going to run. This is now just an if statement. It's just going to always do what it's programmed to do. But this assert, there's like this weird external control over it, if that's a good way to explain it. Let's see. So the assert will generate an assertion error. That's the kind of exception it will generate, right? If I didn't have the assert, so let's say I say is null, and then I try to do something with this, like print it or something. Well, actually printing it will work, but if I try to call a toString method on it, why is it angry with me? Oh, there we go. Now I get this null pointer exception that was generated by that exact line, right? By line 17. Let me go back to. No, again, I think this is. I'll look into the assertion error thing. I think this is a bug on our end, which is irritating, but sort of useful, I guess. All right, we got a few minutes left. Any other last-minute questions? So the plan tomorrow is we'll talk about different types of exceptions and maybe talk a little bit about throw. And then on Friday, we'll talk more about throw and kind of how you can design your own exceptions by inheriting from other things and some of the other sort of error handling patterns that go along with using exceptions. And we're giving you practice with using these new constructs. You're also seeing them again on the machine project, right? And this is another part of Java that is very much used in the wild. I mean, any type of, error handling is one of those things that a lot of programming languages put a fair amount of time and energy into thinking about how to do well. And Java is no exception. So for example, there's a new language from Google called Go, and they've actually spent a lot of time as a community over the past few years thinking about how errors are handled in Go and potentially introducing new mechanisms for using them. And so and that's because and I want to be clear here. I mean, there's two types of error we're talking about here. I mean, when you're a software developer, you make plenty of mistakes, and the mistakes are that you wrote the code wrong. It wasn't written correctly. It wasn't designed correctly. It didn't do what you thought it did. That's one type of error. These types of errors are more intentional, right? It's like if we think about our container that we were designing, I don't know where it went, but I think I just got rid of it. We want something to go wrong, right? If certain conditions are met. Like if you try to create this container object with a negative size, I don't know what to do, right? There's no real way to go on. I should just stop, right? The program should really fail at that point. And Java's exception generating and handling mechanisms gives us ways to do that in sort of a nice way. All right. Try to catch any error. It does not work. No. Yeah, maybe that's the thing. Maybe we turned off being able to catch errors. Maybe that's what we did. Anyway, I'll look into it. I mean, we should probably be a little bit more granular than that because of the assertion errors. This is something we can probably fix. All right. I hope you guys are all well. And tomorrow we'll pick up where we stopped today, and we'll talk a little bit more about some of the same topics that came up today, but we'll go into more detail about them and review them together. So I will see you all then.